guys, so last class we talked about properties of exponents. Now we're going to talk about properties of radicals, and these kind of go hand in hand. And some of this you've already seen before, so we're going to review some of these concepts because you will see them on the SAT, and we're going to actually do a few examples together. So if we have a fraction under a radical, we can separate it with two radicals. So in this example, we have the square root of a over b. And we can separate it by saying the square root of a over square root of b, and then we can easily simplify it that way. So for this first example, it says the square root of 4 over 9. We can separate them, and now the square root of 4 is 2, square root of 9 is 3. So it makes it a lot easier if we can do this. So if we look at this first example, square root of 16 over 25 can be written as square root of 16 over the square root of 25. And now I can easily simplify these. Square root of 16 is 4, square root of 25 is 5, and that's your answer. That's how you can simplify. I'm going to have you try these two on your own. Now let's look at having two factors under a single radical. So if we have this example, the square root of 75, I always try to think of what perfect square can go into this because it makes the problem easier. So a perfect square that can go into 75 is 25. And 25 times 3 gives me 75. So we have 25 and 3. Square root of 3 stays the square root of 3. However, the square root of 25 is 5. And then this is as simplified as it gets. So we put the whole number in front and then the radical out behind. So square root of 25 is 5. Square root of 3 stays the square root of 3. So the answer is 5 root 3. So if we look at this first example, we have 80. So we think about what perfect square can go inside 80. So we can do some guessing. You can just guess and check. Take your calculator. 80 divided by 9. Nope, doesn't work. 80 divided by 16. Yes. So it's 16 and 5. So 80 can also be written as the square root of 16 times the square root of 5. And then we can just simplify. Square root of 16 is 4, and square root of 5 does not simplify, so we leave it as is. It just makes it a lot easier if we go for a perfect square. So I know that 45, 9 can go into it, so I can do square root of 9 times the square root of 5. Only square root of 9 can simplify to 3, and then square root of 5 stays the same. So you try square root of 112. Now, if we have a radical, it can also be written as a fractional exponent. So if it does not have a number out in front, it's always understood as a 2. So this will always be a 2 if it's not written in. Otherwise, they'll tell you what it is. So what you do is you just take whatever this outside number is and it becomes a denominator. So for this case, we have a 3. That becomes the denominator. So the cubed root of a is the same thing as a to the 1/3. So you can write it either way. So for example, the square root of 289 is the same thing as 289 raised to the 1/2. And we know it's going to get smaller because if I had 289 squared, I know it's going to get a lot bigger, but it being a fraction tells me that it's going to be smaller. Because the square root of 289 is 17. So I know it's going to get smaller because it's a fraction. Cubed root of 289 is the same thing as 289 to the 1/3. So if we look at these examples, we have 24, fifth root of 24. So I can write this the same thing as 24, and since it's a fifth root, it's 1/5. So it's 24 to the 1/5. Same thing for this one. It's 63 to the 1/4. So try this one on your own and think about what I told you if the number's not out front, what that automatically means. Okay, well, what if I have a radical and an exponent? well, the exponent goes on top, and the radical is the denominator. So for this case, I have 5 to the 2/3. You have, it's going to be exponent over the radical. So in this situation, we have our base is 6. Our exponent is the numerator. So it's 6 to the 3rd power. And then this numerator tells me it's square root. So my answer to this one is square root of 6 cubed. Second one. This 4 is my exponent, so my base is 3. 4 is my exponent. And then my denominator is the 5th root. So this is the same thing. 5th root of 3 to the 4th power. And you can always do this in reverse as well. So there's an example for you to try. So 2 to the 6/5, try that one. Now let's look at when a number is squared. The original number can be positive or negative. So if I have a squared equals 81, I know that a positive and a negative can give me 81. Here's why. 9 times 9 is 81. Negative 9 times negative 9, let's talk about this. A negative and a negative makes it positive. 9 times 9 is 81. So this is why it can be positive and negative. If I square root 81, they want you to think about it as being a positive value only. So when you square root 81, they just want you to think about it being a positive value. So the square root of 49 is just a positive 7. This kind of contradicts some things that you've done, like if you solve by square root, because we're not solving, we're just looking at what the square root of that number is. It's just a positive value. So hopefully this section does not confuse you. But when we're talking about the ACT and that kind of thing, if you see like the square root of a number, just think about it. But this says find the numbers that can be squared to get the following. 7 and negative 7 can both be squared to get me 49. If I look at 144, a positive 12 can give me 144, and so can a negative 12. But just keep in mind this piece right here, that if you see square root of a number, they just want you to focus on the positive value. Okay, almost done with this, and then we'll look at a couple of examples. If you are cube rooting a negative number, the number will be negative. Here's why. Negative 3 times negative 3 gives me positive 9. But then I multiply by negative 3, because remember, if it's being cubed, you multiply it 3 times. So 9 times negative 3 gives me a negative 27. So this is why anytime you do a cubed root of a negative number, it's going to be negative. So if we do the cubed root, and you can do this on your calculator, but cubed root of 125 is 5. So it'll be a negative 5. Cubed root of negative 8 is going to be a negative, and then the cubed root of 8 is 2. So you can try this one on your own. Okay, last one. This is a little bit more time consuming, but it's finding it's trying to get rid of this radical in the denominator, which you can't have. So what we do is we multiply numerator and denominator by the conjugate, which all that means is changing the sign of your radical to whatever the opposite is. So if it's positive, it'll be negative, and vice versa. So we have 3 over 2 plus root 5. So we're going to multiply this by the conjugate. So the conjugate would be 2 minus square root of 5. And this is where multiplying factors comes in. So now you actually have to multiply, which is why this becomes a little bit more time consuming. So we're going to do 3 times 2 and 3 times negative square root of 5. 3 times 2 gives us 6. 3 times a negative square root of 5 is just 3 root 5. You can't do anything here. That's just how it's written. All over. Now we do the denominator. 2 times 2 is 4. Then we do it to the negative 5. 2 times negative root 5. So it's a negative 2 root 5. They just are next to each other. That's it. And then we do this square root of 5 to these two terms. So 5 root 2. It's now a positive. And then all you do is multiply what's inside. So 5 times 5 is 25. So positive and a negative makes us negative. Square root 5 times 5 is 25. So let's review that quickly. We distribute this 3 to both terms behind. And then down here, we're foiling, or we're distributing. So we're going to distribute the 2 to the 2 and negative 5, and watch your signs. 2 times a positive 2 is a positive 4. 2 times a negative makes it a negative, and then these two pieces go together. You do the same thing with the square root of 5, and when you're multiplying these, square root 5 times a negative square root 5. Positive and a negative make it negative. It stays a square root. 5 times 5 gives me 25. Now we can fully simplify this. So there's nothing I can do with the numerator. It stays the same. And then we simplify the denominator. Nothing we can do with the 4. These two pieces are the same. One's positive, one negative. So they become 0 and go away. Then I can subtract the square root of 25, which is 5. And then my final answer, I can just simplify this denominator. Numerator stays the same. And it's all over 4 minus 5, which is negative 1. Let's do another example, and then you can do it. So we'll look at this number 3. We're going to multiply by the conjugate. So it'll be 1 plus root 3, because it was negative, now it's positive. 1 plus root 3. So now we distribute. This negative 4 goes to both pieces. Negative 4 times 1 is negative 4. And then these two pieces are just written right next to each other. So it's a negative 4 root 3. Now we do this bottom one. We're going to distribute this 1 to both pieces. So 1 times 1 is 1. 1 times root 3 is just a positive root 3. Now we're going to move on to this negative root 3. It all goes together. Negative root 3 times 1 is just a negative root 3. Negative and a positive make this a negative. 3 times 3 is 9. So now we simplify. There's, again, nothing I can do with the numerator. So this stays the same. These two pieces are the same. One's positive, one's negative, so they become 0. We keep our 1, and minus the square root of 9 is 3. So to finally simplify it, we just write it as negative 4 minus 4 root 3 all over 1 minus 3 is negative 2. So try these two pieces on your own.